Hello, my name is Chris Keyack with Keyack Technology Solutions. In this video today, I'm going to showcase how to export CNC files, and I'm specifically going to focus on the DSTV files or NC1 files. And these are commonly used for hot rolled steel like wide flange channels and tubes. And then they can also be used for plate nesting such as your webs as well as your inside and outside flanges, or even your clips or plate materials like end plates and things like that that you might use on the job. So again, we're going to focus on the NC1 or DSTV file format. To get started, we're going to go up to the document manager here, and we are on the drawings and reports tab. And the reason why I'm starting on the document manager is because you're going to select the drawings in the drawing list that are associated to the CNC files that you're going to release. So I'm going to go ahead and type in EW and then let's see, RF, and that will filter out any of the assemblies in here that are end walls or RF here inside of the name of my drawings. Now I'm going to go ahead and select all these, and then I will highlight those parts and assemblies in the model. So it highlights anything and everything that's associated with those, including the end plates, stiffeners, clips, and everything like that. All the stuff that's involved with my mainframes and my end walls here. So hot rolled steel essentially. Now I'm going to come up here to the Tekla menu, and then I will go to the export menu, and then I will go to NC files. When I do that, a dialog box will appear, and we're going to go ahead and go through this setup. Now to get started, the first thing that we need to do is we're going to use these three rules that are already created out of the box with Tekla Structures. We have three different settings for angles, plates, and profiles. And in order for those rules to be looked at when creating the CNC files, we have to turn them on and make them active by pressing this checkbox under the Create column. Now, when we come down here to create files we're going to use selected parts. And we have those selected parts on the assemblies that we're trying to create DSTV files for. The reason why I don't create all parts is because then we would get things that we may not be releasing for fabrication, or we would be creating extra CNC files of cold rolled or reference pieces and things that don't make sense to be exported for CNC files. Now the next thing that I'll explain is let's actually take a look at a couple of these rules. If I go to DSTV for plates and I press the edit button here, you'll see that it actually filters out by the profile type here. There's this profile type B, which means that it's a plate. And you can look up in the help files to understand what these different profile type prefixes mean. But it's basically filtering out certain part types like L for angle, B for plates, and then other profiles that will go underneath these other rules. Now the other thing that you'll want to take a look at here is that there might be some requirements for your machines of what is the maximum size of length, width, and height part of a single part that can actually be fed onto your machines. So this is something that you might be able to evaluate and take a look at. What I see most fabricators and detailers do is they just max out all the numbers here, and then they usually will deal with things that can or can't be run on their actual machines over on their nesting software or their CNC processing software, but that's up to you. Now the next thing is, usually here on the holes and cuts tab, there's just something I want to point out that a lot of fabricators will say that for web plates, they may actually want to just burn everything like that. They don't want to do any holes with punch like they have plasma tables. And if you want everything to be exported as a burn, including slots, then, and again, it's particularly on web parts and web plates, then you can switch this to internal contours, and then that's going to be considered a cut. Now, a lot of times, again, most CNC nesting software and things like that, especially for plate machines, they recognize that, hey, if the machine can't actually do any drill or punching on the plate table, then they will oftentimes just turn that particular slot layer into a burn basically on the machine itself, but that's something you'll need to check out. So I just wanted to point out that there are some settings that you might want to evaluate here. One other common thing that's potentially changed by fabricators, especially on profiles, which is down here, this rule here, but sometimes they may have this on their plates if their plasma table has a hard stamping or a writer functionality. But basically what they'll do is they'll turn on this hard stamp functionality, which is going to turn on the piece mark and potentially the job number. So if you want the job number and then you want, say, for instance, you can just do a text separator here. So we'll just put a dash. And then you want, for instance, the assembly mark or the part mark. I usually do part position here versus assembly position, and I'll tell you why. Because if it's the main part of an assembly and you use part position, then it's going to actually take on the main part mark. And if it's a submaterial mark, like an inside flange or an outside flange or an end plate, and you want that on there, then the part position will take on the submaterial mark. So you may want to set that up. Now, once you've set these here, you can actually go down and you can control the offsets and the size of this text and which surface. Top flange would be top, front would be like the front web of the part, especially like on a wide flange. But essentially, you'll go through these settings, you'll get these set the way that you want, and when you press OK, it's going to update these settings files into your model attributes folder. So let's just take a look at where that's at real quick. If I go in here to open model folder, and then I go into attributes, we're going to see here that there's this DSTV for plates file that was just created, and this .ncfs. You can then copy that file into your MBS firm folder, so that way once these settings are set up on a job, you can make sure that they're in your firm folder, so that way you don't have to set these up again on future jobs. All right, so the next thing that we might do is I'm just going to go to this DSTV for profiles. I'm going to edit this, and again, we might go over to hard stamp and we might turn this on here. Let's just go ahead and say that I'm going to show the part position this time, and I won't put in the project number. And then again, we can change the height of that hard stamp, depending on how wide the flanges are of the pieces that you use on your end walls. I wouldn't make this too large because, say for instance, small W8 by 10 rafters and columns, they may be only 4 inches wide. So you don't want this to be too large. Now, then we've got this set, but there's one other setting here that is fairly important with wide flange, and this is for rolled steel. And you may want to just press F1 on your dialog box here and just look in the help file. But you want to maybe have a setting here if you ever do any cuts that are really close to the flange. This usually only happens like when there's rat holes and things like that for CP welding on wide flange pieces. But essentially here, there's a basically clearance limit from the inside of the flanges to for any web cuts to make sure that your CNC machine doesn't necessarily fail or hit the flange of a beam. So these are just some of the settings that you'll want to take a look at and make sure that you test these out and evaluate these, see what different settings do when you export to your CNC software. All right, so we've got everything set here. I'm just going to press OK. Now, the next thing I'm going to explain are pop marks and contour marking. Now, pop marks are essentially the way here to basically put a small 0 diameter hole or just a small pop or where like your drill or your punch just like taps on the part to create location points on the piece to tell the shop where to fit plates or connecting parts and clips to. Now, this is the old-fashioned way that a lot of fabricators used to use a long time ago before contour marking came out. And so this was the simplest way when a lot of beam lines only just had, the drill or a punch, and it just quickly tapped the piece to make this small little just pop mark or divot mark there in the steel. Now, there are different controls here. You can actually filter out which materials will the pop marks be on and which secondary parts that are attaching to the main part. So if you only want plates or angles or here, this is actually good with what they have set up out of the box with like round tube, basically like a center point of any kind of pipes or anything like that that are coming in or attaching to the main part. That could be pretty handy. Then here we've got plate profiles going on to wide flanges. So I profiles means like a wide flange shape. And then here it shows the pop mark location is actually lining up with the left side of the plate, and then it's actually putting pop marks wherever there might be any holes, like in a shear tab or a clip. So that way the pop marks actually tell the shop where to line the holes up with the pop marks to fit that onto the main part or like the beam or the column. Then essentially there are some clearance distances here. So like it's basically looking at the edge of the material and how far away should that pop mark be in order to place it. So that way, again, this is just looking for your CNC machine, like your drill head. You don't want it to come in and hit your flange of a wide flange beam. And then you can essentially look at the help file to take a deeper look at these settings. I would say most fabricators don't actually use this these days, but I did want to explain and show you how this can be used. What I'm seeing most of the time nowadays is actually contour marking being used. However, if you wanted pop marks to be used on specific parts or settings, you need to press the pop marks button here in order for those that rule or that CNC setting to actually include pop marks in it. If this is unchecked, then even though those settings were set up in the dialog box for the pop marks, it won't include that. So you have to check that there if you would like that. Now I'm going to go ahead and explain contour marking. If I go to the contour marking button here, it opens up this dialog box. I'm just going to go ahead and add a rule in here by pressing the add button at the right hand side of the dialog box. And I'm going to tell this that I want contour marking potentially for all profiles. Or if I only want this on my wide flange and I don't want this on plates, then I can also change that if I'd like to. Now here for secondary profiles, again, I can filter by certain types, and you can add multiple rows. So it doesn't have to be just one row here. You can have multiple rows of rules. Now, what I'm going to do here is I'm just going to leave this all as is, and then a couple of options that I just want to explain. And again, you can look at the help file. So if you just press F1 on your keyboard, it'll open the online help, and it'll explain each of these options in a little bit more depth. But a couple of things that I'll just highlight to you is that, do you want secondary contour marking? Well, yes, we basically do. I wanted the secondary parts to be to have the contour marks there. And then there's this option for punch or powder. Honestly, in the DSTV file and specification, the geometry is going to be the same. It's just basically the line work or the contact surface of parts to other parts, like to the main part of the assembly. And it's just a different operation, punch versus powder. Most of the DSTV and CNC processing software for the CNC machines, they'll be able to identify it from either one. I just include both usually, and then they will pick one of those that the machine is capable of using. But again, the geometry is the same between both. It's just a slightly different operation defined in the DSTV file. Now, this hard stamp option, so this is pretty important. The hard stamp that I was showing you before up here in the main rules, that was for the main part of the, or the piece itself that's being exported. And again, that's usually going to be like the main part of your assembly, like your beam or your column. And here, this hard stamp inside of this dialog box and in this rule is basically saying, should it take any submaterials that are welded to this part that the CNC file is being exported for? Should it show a hard stamp of other parts attaching to this? Now, you have to determine whether or not you want to turn this on. Some fabricators will turn on the contour marking so they can see the outlines of the parts and plates that are attaching to their pieces, but they don't want the piece mark drawn because of the time it takes for their machine to potentially draw all that out. So you'll have to look at the efficiency savings versus the quality control savings of actually putting on the secondary materials hard stamp and drawing out those piece marks on the material. Now, the last couple settings here are this mark parts welded on site. No, so this is like anything that's field welded to these pieces. You don't want to have any contour marking for that usually. And then the last thing here is this edge distance. Now here a lot of fabricators will tell me anything from like 1/2 to 1 inch here. And again, this is the same thing where let's say that whatever mechanism that's on your CNC machine that actually does the scribing and draws the contour or the piece marks, essentially it's basically saying what is a start distance away from the edge of the material that the CNC machine needs as a protection in order to go ahead and start that contour marking. There might be tolerances on the steel itself, or just, making sure that the marking system doesn't, have any issues with burning or doing anything near the edge. Then essentially this is that setup that you can do. What's the edge before it starts actually doing any contouring here. Now, once you've got this set, you can actually save this as standard, these settings, so that way these are used. And again, this goes in your model attributes folder, and you can put that into your firm folder, kind of like what I was showing before. And so once we've got these settings all set the way that we want, we'll just press OK. And here it's actually giving you a message. Both the pop marks dialog box and this dialog box give you a message and say, hey, contour mark settings affect numbering. And the quick explanation behind that is that if you think about it, if you're making parts actually scribing the contact surfaces of other parts attaching to it, well, you might have geometrically the same exact web plate from one rafter to another, but if you have different contour marks or different lines being scribed on one web plate versus another, well, they have to get different piece marks so that way the scribing lines are accurate. So that's why it's telling you here that contour marking affects numbering, because if you had different pieces attaching and different scribe lines happening from one part to another, they're going to need to get different piece marks. So I'm just going to go ahead and press OK here. And if I want to turn the contour marking on, I can choose for which part types that I want this to actually be turned on. So let me actually just turn this on for both of these here. And then I'm going to go ahead and just save this as standard, so that way I could copy this into my firm folder. I've got all the parts selected in the model, and I'm just going to then go ahead and press the Create button here at the lower left-hand corner. Now, when it goes through reading all those parts, it'll tell me when it's done here at the lower left-hand corner by saying NC files have been written for plates and profiles. If I want to take a look at the log file here to see what it actually did and if there were any errors or any files that it couldn't create, then I can read through this and then I can see which piece marks that I need to go potentially look at. All right, so that's the creation of the NC files themselves. They actually get created in the model folder. So I'll go to the Tekla menu here and I'll go to open model folder. I'll then go to my NC files subfolder, and you'll see here that all of the main profile parts, like for my rafters and my hot rolled steel, all of that's here. And then all the plate materials that were run and passed through that rule are actually in this plate subfolder. All right, so that shows you how to run the DSTV files. All right, now let's go ahead and take a look at some of the parts that have been processed, especially on a 3-plate rafter assembly. I've got my web piece here, which this is going to be RF1-3. That's the part position or the piece mark. And then I'm going to look at this outside flange. So this is OF2. And let's just go ahead and take a look at these. Now, I want you to see in the model that there's a flange brace clip on the web, and then there's a bunch of purlin clips attached to the outside flange, this OF2. So let's go ahead and go into this basically CNC file viewer. This is from ATEC, their Steel Solution software. This has got a great viewer. It'll bring in a lot of DSTV files. And so I love using this because it helps me visualize essentially the outputs from Tekla. Now, if I come in here, I can see that on this web plate, it actually did hard stamp the project number, which I just hadn't set that actually in the project properties, but that would be the job number there. And then it's got a dash RF1-3, which is the part position of this web plate. Now then I also can see here that this clip is being attached here to the bottom, and you can see where that 1/2-inch offset is kicking in. So it's scribing the lines, but it's taking this 1/2-inch distance away from the edge of the materials, and then basically just showing the left and right side of the plate, and then it's holding it back away from the bottom of the web there. So here I could use that to actually place the stiffener, but the CNC machine won't fit, have any issues by going too close to the edge of that web. So this looks pretty good here for what I'm seeing. Now if I go to this other part here, the outside flange, this is actually a little bit problematic potentially. This seems like a lot of scribing work. What's happening here is the web part along the entire length of this outside flange is actually being scribed down the middle. Now I could probably disable this toolpath or eliminate this here in the CNC file before I run it, or in Tekla I would actually make a filter that doesn't allow me to export any scribing information for like these basically webs that are coming into the flanges. So here I can see all the clips though, that's really great to see, and then I see the piece mark. And again, you can control a little bit of the offset and the locations of this because these are a little bit too close to the edge here. And so I've seen, again, a lot of fabricators, they end up turning these piece marks off and they just have the scribe lines just to give themselves something there, especially since they use a lot of standard part marks for clips on flanges. So you just have to really evaluate what is the data that you want when you do use the contour marking or the scribing. All right, next let's go ahead and take a look at a couple of wide flange pieces. All right, so now I'm over here at a end wall rafter, and this is going to be piece mark ER-1. So let's go ahead and go into our CNC software. We'll add a part, import DSTV, and I'm going to go find this ER-1. All right, so now that's there, and it gives me both or all three views. It gives me the top flange view, the bottom flange view, and the front web view here. And I can see where there's these flange brace clips being attached to this. And again, it's actually looking at that setting away from the inside flange there to make sure that we don't have any tooling issues where the tool that's actually going to do the scribing might foul or run into the flange of this wide flange beam. We can see the holes are input here. And then we have the clips here for our purlins on the top. And again, this is where I need to adjust those settings for the hard stamp locations or potentially not show those. I'd probably center those and just not have any offsets there. And then you'll see the web on the far side, but that isn't a scribing thing. That's just showing you that there is a web on the far side. So for wide flanges, it might make sense to do this full scribing of secondary pieces, but not maybe on your outside flanges for 3-plate. So then we've got the front face, and then we've got anything here on the bottom that we might have scribed. And this gives you a full visualization of exactly what's inside the CNC file. One last thing I want to explain is that these DSTV files are essentially just ASCII or text files. If we actually take a look at this ER1 that we were just looking at in the viewer, and we just say right-click, open with Notepad, you'll see here that the profile, the job number, the piece mark, the material grade are all described here in the header, and then even the profile type and some of the dimensional information about that profile. And then here we have descriptions in different blocks. So the AK block is basically the external contour or like the polygon formed for each face. And that's what these letters here represent, is the different faces that it's describing the geometry for. The KO block here is basically that that contour for like any kind of the hard stamping and lines that are drawn here, and it basically has individual points that form all the line work. And then you'll see a lot of those in here, especially if you have a lot of scribes. So you'll see like multiple blocks of that. The SI block is essentially a hard stamp block. And I can tell that this is a submaterial being shown on here because it's at a pretty good distance away from the end of the piece, and it's down here in the rest of this contouring section. And then here you'll see multiple versions of this as well, and even though it's the same piece mark, it's in different locations because we have different clips along the length of that piece. Also, you'll see like in some of the blocks, basically the holes. So if there's any holes and slots, that'll also be described in here. And then essentially what I do is I usually give clients the DSTV specification because they may want to extract information from these parts or be able to troubleshoot them and do things themselves. And so just wanted you to see that these files are simply just text files with data, and you could actually read these in human readable form as long as you can take a look and compare this against the DSTV spec. For additional training and setup and configuration of MBS SlideRule with Tekla Structures, please reach out to me at my contact information shown, and I'd be glad to help.